Most of my videos thus far are about NASA's projection outside of our planet. What are we doing at the sun? What are we doing with our satellites and their new missions coming up? So this one's going to be focused on Earth science, which is another part of NASA that a lot of people overlook, unfortunately. A lot of people like to see the deep space and are we alone kind of thing. What they don't realize is that NASA and NOAA have such a strong influence on our decisions, both from policy wise as well as an environmental perspective. So we're going to step through a couple examples of the criticality of Earth sciences and how it plays into our lives. So to get us started, here's an image of the satellites that are currently deployed around our Earth that are operated by NASA. These are constantly picking up on all sorts of sensor data to help us better make decisions. You may remember in June of 2020, NASA and NOAA had observed a large dust storm originating from the Sahara Desert in Africa, coming the 2,000 miles over the Atlantic Ocean and then dumping in the Caribbean. Naturally, with everything else going on in 2020, it was pretty hyped up at the time. Now, what people don't realize is this is quite normal. Yearly, hundreds of millions of tons of dust are picked up from the deserts in Africa, blown across the Atlantic Ocean. That dust helps us build beaches in the Caribbean and fertilizes soils in Amazon. It has a lot of benefits and it is quite normal. But we would not know that if we hadn't been observing it so often. So these illustrations are great for us to learn from. Another great example of how the world is connected is that in late August and early September of 2020, three storms occurred just 2 weeks apart in the Korean peninsula, causing floods, mudslides, and several casualties. In a recently published article in Geophysical Research Letters, evidence was presented that these storms had more than enough energy to disturb the jet stream, creating an atmospheric wave train that amplified weather conditions and increased the likelihood of wildfires in North America, which were very evident. Stratospheric ozone, also known as the Earth's ozone layer, helps shield us from the sun's harmful ultraviolet rays. Compounds like CFC11, a chemical once considered safe and widely used as a refrigerant and in the production of insulation of buildings, rise to the stratosphere after emissions on Earth's surface. Once in the atmosphere, the CFCs are broken down by the UV light, and the result is the destruction of the ozone molecules, both reducing the stratospheric zone concentrations globally and contributing to a hole in the layer that appears over the Antarctica in the spring. After production ceased, scientists still expected CFC11 to continue leaking over the years from existing products, but at a gradually declining rate. Because of this, the gas is among those monitored at the global scale by NOAA. In 2018, the NOAA first reported a smaller decrease in the decline of atmospheric CFC11 than expected. The numbers didn't align with trajectories based on the CFC's 11 production ban, hinting that something had changed. NOAA had helped track down the origins of much of the new emissions of the CFC-11 thanks to its geographic distribution. Two of its stations in South Korea and Japan were positioned close enough to the source of researchers to track much of the new emissions back to their source, which was East China. Scientists understand that Earth's magnetic field has flipped its polarity many times over the millennia. Earth has settled in the last 20 million years into a pattern of pole reversal about every 200 to 300,000 years, although it's been more than twice that long since the last reversal. A reversal happens over hundreds or thousands of years and is not exactly a clean backflip. Magnetic fields morph and push and pull at one another, with multiple poles emerging at odd latitudes throughout the process. Scientists estimate reversals have happened at least hundreds of times over the last 3 billion years, and while reversals have happened more frequently in recent years, when dinosaurs walked Earth, a reversal was more likely to happen only about one every 100 million years.